Hey everybody, welcome back to another round of test-driven development for iOS. This is my third screencast on the topic. The last time I showed you how to TDD a simple view controller. And here it is, just to remind you. We have a label up here and two buttons, one to increment the count and one to decrement the count. And while this is very simple as it stands, you can imagine it being part of a larger thing, such as keeping score for sports or changing the count of items that go into a shopping cart. So it's still very practical. But we're going to pick up where we left off last time, which was that everything was glommed into the view controller. Here's what we created last time. We have the test code over here on the left. On the right side, we have the production code with the header up above and the implementation down below. And that's it. That's the full implementation right there. But it's still doing too much because while the view controller right now is very short, it's such a natural, common tendency of programmers to jam more and more stuff into the view controller. And here you can see it's keeping track of this count. What we're going to do in this round is pull this out into a proper model view controller.
Model view controller.
This diagram is from Apple's documentation of Model View Controller. I've got the link to that documentation in the blog post that accompanies this screencast. You should go check it out if you haven't read it. But basically, and this should be review, I hope, in the MVC world, you've got the view, and that's like, your buttons and whatnot. The user taps on the view, which invokes an action in the controller. At this point, it is all too common for the controller to do a whole bunch of stuff. Resist the urge. We are going to instead have the controller update the model. This is where our count is going to go. And the model will then send a notification back to the controller, but the model doesn't know anything about the controller. The model's just sending out a notification saying, hello, anybody who's interested, here's how I changed. And that's an important way of breaking the dependencies. The controller then takes that information and updates the view to match. So the way we TDD this, I showed you the left-hand side last time, which is that for the user action, there are a few tests we can run to verify the user action portion. Again, this is from last time. Say we have some buttons that we want to TDD their behavior. The way you do it is you have an outlet that points to an action connected in the nib. There are three tests you can write to drive this this design. Test 1 is the outlet hooked up? That is in this case, is there a button that we can access? Test 2 is the outlet connected to the action? That is, in Interface Builder, is there an actual connection to a particular method that we want? And then test 3 is go ahead and invoke that method directly, as if the user had done it, only the test is doing it. So that's how we TDD the user action portion. The controller updating the view, that's easy. All you have to do is have the test check the state of the particular view, like the text label, that it was set correctly. So how do we get to this side? Well, updating, again, could be easy if the model were a real model. If your model is a simple aggregate of values, then there's no need to mock it. Just use it and check its state. But in this case, I actually want the model to do some work. I want it to post a notification. I'd rather not have that happen. So what I'm going to do is I'm going to mock the model and make sure that the update, the message being sent to update it, is correct. Basically, I'm verifying the contract of the communication that goes this way. And then I'll show you how to TDD. Well, first we'll TDD the model itself, and then I'll show you how to check the notification. That's the plan.
That's a direct order. Do it now.
So let's do it. The first thing I'm going to do is Command U to run my current tests, just to make sure I'm starting from a good point. Okay, test succeeded. We're good. What I want to do is use, let me switch this view. I want to use dependency injection to create a counter class. I'm going to actually create a mock counter, and I need OC Mockito. We didn't use it before, but now I need it. Let's bring in the iOS framework, drop it into our test target, not the app, and add the import. And now I can say mock the counter class. And now I want to provide that using dependency injection in through the initializer. You may remember this is something I explained in my first session, was that you can, for dependency injection, you can either do constructor injection or setter injection, but to prefer constructor injection if you can. So there we go. Let's move stuff around a little bit, and let's see if we can get this to work as a refactoring. We want to start from green and end in green. So let's create the counter class. Put it in the app, not the tests. Get rid of noisy comments. Come back to the test, and I need to import it. I like to do that like this, specifying the collaborators. That should now satisfy that. Good. Now I need to create this thing. Let's bring back our view and see about creating this initializer right here. Now if I were using app code instead of Xcode, I would just click here and then Option Enter, and it would, app code will automatically create everything I'm about to do, which is an empty stub that does this. Counter, and app code would also add this forward declaration of the counter class. You're all using forward declarations instead of importing the headers when you can, right? Now let's take this, bring it down here. Now I'm about to write some code. Actually, I'll go like this. I'll let Xcode write some code. And you may complain saying, hey, that's not test driven. There are a few things where I make exceptions just because it's good Objective-C style and we're good Objective-C programmers. So I'm not going to create an initializer that doesn't actually like allocate self and call super and return self. I'm not going to do that, okay? Neither are you. So I'm not going to take time to try to write a complicated test for that when it's never going to happen. All right, now I should be able to Command U, and our refactoring should be pretty good. It is. But, word of warning, by adding this initializer, where before it was just calling init, I've now changed the designated initializer. There's probably another place that's actually calling this. Let's look for counter view controller alloc. There's the test, and oh, there it is in the app delegate. I really need to fix this up as well. Now, I normally have tests for my app delegate as well. I'm not going to bother this time because I've got other things I want to show you. But you can read all about that in Graham Lee's excellent book, Test-Driven iOS Development, about how to write a unit test for your app delegate. All right, so that should still be all happy. Let's Command U. Okay. Now let's add our first interesting test. Actually, let's go look at what I want is I want increment count. Right now there are a couple tests for it, I think. Instead of doing actual work here, I just want it to tell the model, hey, increment. A quick way to find the tests that are really now going to be outdated is to comment this out. Command U. And there, yes, test increment once should add 1 to the count label. Twice should add 2 to the count label. I'm going to get rid of these. They are no longer testing something that I want. Delete them. Instead, I want to say increment count should ask counter to increment. Let's verify the mock. Where's my mock counter? Oh, it's local. I need to promote that into the test fixture as an IVAR. But I'm doing a refactoring right now. So let's comment this as yet unwritten test out. Refactoring should always go from green, that is passing, to passing. Okay, so that's good. Now we can bring this back into play of the thing that we were working on. Mock counter. I want to verify that increment, a method that is not written yet, is called when the system under test gets the increment count action. And there's no given, like that. Now this is the compiler's complaining because there is no increment method on counter. Well, let me open a new tab. Command T, and let's bring up the counter, the header up here. I'm doing Option, click and double click on that. So we've got the header up here and the implementation down here. The method is called increment. Again, AppCode would do all this for me. So now if we switch back here, I think the compiler is satisfied. Let's Command U. Okay, remember this is good because it compiled, built, and ran and we have a failing test, which is the first step we need in order to make progress. Now we have something that we're satisfied, verifies what we want. Now we can come over here. Let's get rid of these. And this will call, I need to get that that model class. Where did it go? We're ignoring it. We no longer want to ignore it. I want to keep track of it. You may prefer to use a property over an IVAR. That's totally fine by me. I just like IVARs. And now back to increment count. I should be able to say, hey counter, increment. But it doesn't know what counter can do. All it has is a forward declaration. Now we need in here to provide the real thing. Let's command U. That should be the simplest thing to work. That's step 2 of TDD. And it passes. That's good. And I can feel in my bones that there's nothing really to refactor yet. So what we've TDD'd so far is the controller updating the model for one action. Now let's TDD the model and see how notifications fall out of that. In this tab, I've got the counter view controller stuff. Let's switch over to this other tab where I have on the right side counter, that is the model. But I don't have a test for it yet. Let's make a test called counter test. Make sure it goes into the tests. And as usual, get rid of the cruft. The class under test is counter. I'm going to use Hamcrest, but I doubt that we'll use any mocking. And we're ready to start. What's our first test going to be? Well, I'm going to say test increment 1 should yield 2. Starting from the bottom up, here's kind of what I see is that we assert that an integer of SUT count is equal to 2. This happens after when we do an increment given that we set the count initially to 1. Of course, we have to create the system under test. Like that. And we are relying on a property that we haven't created yet. So that's the first thing the test is driving us to do. Create an assign property of type NSInteger called count. That should satisfy things. Command U to try to get step 1, which is a failing test, and it fails. What is the simplest thing that will pass this test? That is to simply set the count to 2. Yes, it's dumb. Command U. So, as a reminder, the reason I do this dumb implementation, it verifies that the test wiring is correct. It also shows me that I don't have enough tests because I can look at this and say, I know this is wrong. Let's make another test. I'm going to copy and paste this one. Say incrementing 2 should yield 3. So given that the count is 2, after an increment it should be 3. Command U. I expect this to fail. Now the easiest thing, the simplest thing, is to increment it like that. Command U. We go from step 1, failing, to step 2, passing. Now step 3 is to refactor. There's nothing to refactor in the production code, but we do have some duplication now in the test code. Let's bring this variable up into the test fixture. And let's create a setup. That will create the counter. And just to pair this, I'm going to set the SUT to nil. This is essentially a way of the testing our deallocation of the object as well. Without this, it won't be deallocated until later, and I'd really rather have it go away inside of the test. So now we've done this refactoring, which should still pass. Command U. Okay. Now, let's get more interesting. Now I want to test notification. Increment should post model changed notification. How do we do that? Because what I want is, well, I want to do an increment, and when that happens, then I want the notification. Well, the way to do that is to have the test listen for the notification. So let's add observer self. That is the test case. Selector is going to be counter model changed, and the name of the notification is going to be counter model changed, and we're listening for that particular object. Okay, and likewise in the teardown, let's just clean that up and remove the observer. And when this happens, when the notification comes in, let's increment a count. Call it model changed count, which I'll put in the test fixture. Now you see the test can say assert that that int model changed count is equal to 1 after an increment. That looks like a pretty good test. I need to create the name of the notification as a constant. Like that. defined it now, or we've declared it, now we define it. There. That should satisfy the compiler. Let's Command U and watch it fail. Down here, yeah. We didn't actually get the notification because we're not posting the notification. So what is the simplest thing that will pass this test? Roy Osharov actually has a great blog post about this. I'll include the link in my accompanying post. The name of his post is 4 questions that will help you create the simplest thing that could possibly work for TDD. And he has it's really about the question, what is the simplest thing? What is the thing that's going to drive tests? We've already seen one of those, and that is to hard code things. By hard coding a return, or rather the count, that forces us to write more tests. Here's another, is to, let's post the notification, but I'm going to do something bad. You see where I'm posting the notification? I am doing it before the count is incremented. That's wrong, right? Yeah, it is wrong, but it will pass the test, I think. Let's see. Command U. And it passes. So now we know the test is receiving the notification posted by this method. Now this is wrong. All that means is that we're missing a test. Test increment should post notification with new count. What I'd like is for the our notification handler to not only increment a count, but also grab the object. So let's get the notification object, cast it to a counter, and from that get the counter's count into a model changed value like that. So the notification comes in, it increments the count so we know how many notifications come in, and it holds onto, well, it accesses the notification object, treats it as a counter and says, give me your count, let's hold on to that. So now I should be able to say, clean up some junky lines there. Assert that integer model changed value is equal to, oh, I don't know, 2 again. When we increment, given that the initial value is 1, right? Yeah, let's do that. I expect this to fail because this order is not correct. Command U. It fails. Now, let's pull the increment up. Command U. And it passes. See the tests that have been driven out by looking at code and saying, we need something to drive the verification of this. Again, I can already hear the complaints. Wow, that's a lot of work. That's a waste. No, it's not. Because what if somebody comes along and changes it? I know that I now have a test that will fail. It'll alert me because this is a requirement. Now, if the order doesn't matter, it doesn't matter, right? You don't need a test for that. Okay. That's increment. Let's go ahead and create decrement, but to save time, I'm going to do that offline. Be back in a second. I'm back. What I did while I was away was copy all my increment tests and change them to decrement tests. So things like test decrement 2 should yield 1. Everything, kind of flipping around a little bit. And the resulting code is very similar. It just has the count being decremented by 1 instead of incremented. We do have some duplication to be refactored. Look at that. Let's take this out and do an extract method on it. And I'll call this, as soon as it's done analyzing, post model changed notification. I spelled it wrong. Notification. Do it like that. Do it like that. And I was a little lazy on this on earlier screencasts. I wouldn't leave this extracted method up here. Do bring it down, because that's what Uncle Bob teaches us to do, to make code read top down. That looks better. Let me Command U to see that we go from green to green. Our refactoring is good. We've now successfully TDD'd our counter model, which has the count state and an increment method and a decrement method, and we've not just verified, we've test-driven the fact that it is posting a notification when the model changes. So we've kind of have the arrow going out. Now what we have to do is get the rest of it back so that we deal with the arrow going in to make sure that the controller is listening to these notifications and doing the right update when that happens. Let's switch tabs now, going from our model, the counter, to our controller. And what I want to do is add a test that when we receive a notification, we update the view accordingly. Let's add that test in here before the decrement stuff, which we haven't gotten to yet. Say model change notification should update count label. Or I expect, well, here, like that. I'll just pick an arbitrary something here that the count label I expect to be 2. Here's the meat and potatoes. This might get a little dicey, and it's something to remember that when what I'm doing is having the test post a notification. This is normally not a problem. I've never had this be a problem, but be aware that if you do this, anybody that's listening for this notification for this particular object, or say if the object of choice is not specified, so it's just listening to any broadcasts, something else in the app might pick it up and respond to it. If it's doing something that you don't want to have happen during a test, well, if it's, that wouldn't be a good thing. But I've never had it be a problem. Just be aware that it could be a problem. And we're observing the counter. Say, given that if when we ask the mock counter for its count, it will return 2. Let's try that. Command U. I expect this to fail. Good. Now, over on the production side, let me get rid of the header. I don't think I'm going to be playing in there. Let's make this pass by having it listen, add observer, self, selector, say I'm going to call that model changed, the name of the notification, and I'm going to do this as the simplest thing that will pass. Right away, I'm going to go ahead I'm in ARC, so I don't need super dealloc, but I'm going to make a dealloc that's just going to do the right thing. Why? Because it's the right thing. Okay? It's just habit. It's good habit. If you're going to add an observation, stop observing when you go away. Now, let's implement this. I'm going to put it down here, just so that the code reads more top to bottom. And what should it do? It should do something an awful lot like this, except that this is left over. This is still operating on the old count rather than the counter model. But let me grab this, bring it down here. And I'll say like that. Let's see if that works. It does. But this is not a nice thing to do. I'm listening to any and all model change notifications, and while I operate on my own model, rather than extracting it from the notification, which I could, still, I don't want it, in case there's a stuff out there, I don't want it to be listening and operating unnecessarily. So let's add a test for that. Say the test model change notification from different model should not update count label. And here you may remember that by default our count label is 0, and let's say here I'm going to grab this, except instead of sending it on the mock counter, I'm going to send it on a different counter here. not a mock, I just made it, and I'm gonna set that to something. But I also want to change the current state of the mock to something other than 0. I want to make sure that, say, something is in flight, the model is in the middle of changing but hasn't sent us a notification yet. It's still crawling along while something else, a different model, posts a notification. I expect this to fail. It does, and the easiest thing now is to observe only our model. Let's try that. Let's see if that passes. All right. Now the controller is listening to the notification and updating the view accordingly, all through TDD. But there's another possibility, and that's that the controller doesn't exist yet. Only the model exists and has been set with a certain count, and then the controller is created. Right now, as it stands, our view is going to just show 0 because that's been our assumption up until now. There was no separate model, but now there is. So let's take care of the view correctly showing the initial state when the view appears. Let's go back up to that test for the initial count label should be 0. Let's change that because that's not necessarily true. Let's say it's gonna. What's the when? What is the condition? I think the condition is view will appear. I don't really care about the animation. Given that mock counter count will return 42. There we go. That looks better. That fails. Good. Now let's add view will appear. I'm going to call super. Again, I'm not TDDing that. I'm just doing that because I know that it's the right thing to do because that's how you write it. Now, at this point, I could call model changed. Maybe I will. There is no notification really. It's a little funny, but it kind of makes sense to say, hey, the model did change from whatever I don't know about. Yeah, see, that's simple. I thought about extracting things and having this call something else, but it's simple and it works. All right. Let's clean up decrement. What I want is to get rid of this other cruft of what decrement used to be and say decrement count should ask counter to decrement. Like that. Run the tests. It fails. And really it should look more like that. Run the tests again. And they pass. And now Nothing is calling this. This would be more obvious in app code, that it would like make this gray to indicate nothing's really calling this anymore. And I really don't think we need this. The old original brute force count. Let's try that. Yay. Want to see it run? Increment. Decrement. I have now TDD'd a separate model out of the view controller. So now the view controller just says, hey, go talk to that other thing and tell it what to do, and pay attention through a notification if it tells me that it's changed, and if it's changed, I'll update the view. So now the view controller is more ignorant, and that's good. Ignorance is bliss. So that's it. Thanks for watching. Come back next time. I'll probably do something like a table view, and I'll show you how to TDD a table view. How about that? All right? Till then, take care.